this. Okay, the next problem we're going to look at is our last homework problem, 520. 520 is going to be the design of a crank rocker mechanism this time. And we want to specify L1, L2, L3, L4, and the crank speed, which is our W of our crank, or W2. Now, let's take a peek at the design of the crank rocker. And the design of the crank rocker is going to be on page 116. And here's kind of like the together, this is a crank rocker mechanism. Here is, the sizes that they happen to have. Here's our A, and this is going to be the center point for our crank. Okay. And then D is going to be the center point for the rocker that's going to oscillate back and forth. Okay. Now, the information that we're given in our problem is we are given a Q. Now, Q means that we have an even oscillator, meaning that the entire throw, which is 100 degrees, we're going to be oscillating 50 in one direction and 50 in the other. And it's going to be even. It's going to be a symmetrical cadence, if you would. Okay, this is not a quick return. This is going to be even on the out and on the in. Okay, and that's what our Q means. It means that the quicker stroke has to be divided into the longer stroke, but because it's one, they're both the same value. Okay. And then additionally, you'll see that our T is equal to 3.5. 3.5 just means for one revolution or one rotation of that crank, then it's gonna be that value. So then we can figure out our W using that. Okay. Now, as we look at our problem and we look at the construction, okay, there is going to be a little bit of information that we have to just kind of like start with, okay? And that little bit of information that we're going to have to start with is going to be the length of our like L4 or L4, okay? And then also kind of the placement of A, and then we might have to shift it around a little bit, okay? So, so this is a design process. It's not perfectly going to be like step 1, step 2, step 3 and such, but we will be able to construct it kind of using some of this information here. So, let's get laid out our throw angle and what we think we're going to be using. So I'm going to go back over here. Right now, this is just kind of showing our, first is going to be our crank here at link A, or I'm sorry, at point A. Then this would be point D over here, if we're using the same letters that the problem used. So I'm going to go over here and I'm going to call this point D. Okay. And I'm just using this from a previous problem. So don't really worry too much about layout here yet, because there's nothing specific. It's from a previous problem. Okay. So that's point D. So we know that on point D, there is going to be that link, okay? And I'm just going to simply draw from here, and I'm going to go vertically up for right now. I'm going to go vertically up for right now. And then I am going to add a dimension from here to here. I'm going to add a dimension. Should have made it. So I'm 3 1/3. What do we want that number to be? Any preferences of the length of link number? No, it can be in whatever we want. We're only given angle. Yeah, yep. Mm-hmm. Let's work with inches. How long do we want that to be?
5, but I had a question.
Yeah.
How come you don't line up frame A and frame B?
They don't necessarily have to be. So that'll come in the construction that we have here. Okay. So hold on just a second. Okay. So now the next thing that we want to do. So if this is 5 inches long, right? We're using this as 5. So we're the designer, and you'll have more information, to start off with. So this is gonna be the endpoint of link number 4, and we have this at 5 inches. So I'm gonna put my little circle on the end here. And this is gonna be, I think this is C2. Okay, we're gonna use that as C2 for right now. Then what we're gonna do is we are gonna draw our throw angle. So it's set in there that we were going to be, was it 100 degrees, right? So I'm gonna rotate. And I'm gonna start at my base position down here at the center of rotation. And I do wanna do a copy, so you wanna hit C here. And I wanna go 100 degrees. Okay, 100 degrees. Now, I don't like that angle because now if I want to go in line with it, unfortunately, it's gonna be kind of weird. So I'm gonna take and I'm gonna rotate this again, and this is again part of that design process. And I'm gonna rotate those two, and I'm gonna rotate them so they're about, I don't know, here-ish, right about there, okay?
That's nice.
It's a what? Not a 90-degree angle. This is my throw. So this is my,
Oh.
this is my 100 degrees. This is my 100 degrees. Yeah. Oops, I should change that to dimension layer. There we go. That's my 100 degrees on my throw. Now, and here again, this is going to be, how can I say it? This is going to be something that as the designer and you knowing what you're designing this for, you might have some additional constraints as far as space and where you want your crank to be. So what I'm going to do now is we are going to, and I'm actually going to change this color so we know which one is our closest and which one's our furthest away. And I'm simply going to draw a line, and we're going to go from center of C2 to the center of C3, okay? And I'm going to draw a line out here that I want it to extend to, okay? So I just want to extend that line so it's along that same path, but I just want to go further with it, okay? All right. Now, I'm going to move point A onto that line. And I'm going to go, I don't know, where, well, there-ish, okay? All right. Now, what I've done is, because this is a Q is equal to 1, this is a Q is equal to 1. That means that when I'm in my outermost position, and these are laid out with one another, that's going to be its extreme, it's C2, right? And then when I'm all the way back in, this has to be overlapped in exactly 180 degrees from where that was originally, because it's the same amount of time. So if my revolution is going around an even amount of time and I'm rotating, and I'm just gonna draw right now my, for instance, just a random length. If I say that this is laid all the way out, extended, 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 if that is to come all the way back and be exactly 100 degrees backwards, then that means that when this is in its retracted position, it has to be exactly 180 degrees on the other side, right? Because this time going from here has to be the same time going back to here, right? So there's your layout. That's it. So now, well, hold on. So now I would make this line along here, extending, it's the easiest way to do it. Extend back to there. And now that's going to be my B1 position. This is going to be my B2 position when I pick my actual number. Okay. So, so this is gonna be B1. Now, to get these actual values, okay, I need to pick my crank, right? So before I really even pick my crank here, I know I didn't try to, I wasn't trying to make that confusing, but I want to now look at, all right, what's my distance from the endpoint of this to the center of this? All right. And that right now I have at 12.6 inches or 12.598. Okay. So if I take that and I divide that by 4, like we did before, because we're still using that same relationship as L2 is going to be 1/3 of whatever L3 is. Okay. So if we take that and we take 12.598, and that doesn't mean we have to work with these numbers. Remember, this is just kind of laying it out. And we divide by 4, we're at about 3 1/8. Okay, 3.14. So now if I put my radius here, 3.1495, that then would be my new crank if I wanted to use that. So so if I go to my object line and I extend this out to here, okay, then I'm going to have my B2, my B1, and my A. And then this would be the length of number 2.
Picture left side.
Yep, yep, exactly. So then I would do an aligned dimension from that center to there. And that'll be my length of number 2. Yes, Jacob.
You could make L3 as long as you want.
You could, as long as it was at least 3 times longer than L2. So it doesn't have to be funny numbers. And I would actually suggest real design is you would then round to numbers that are going to be 3.5 or 3 5/8 or, 4 inches, whatever they might be.
You could make it 3,000.
L3, yes,
Yeah.
L3 does not have any bearing on that throw angle. Only L2 does. Yep.
I'm just wondering, I was actually wondering, I just rounded it to 12.6, so I'm like.
Exactly. Yes, 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 yes.
but
You absolutely can.
you just put L1.
Yep, yep. And then if you change it, it just has to be at least 3 times longer than whatever L2 was, is what your L3 has to be. So is that more helpful? I think it is. I know it is. It's more detail.
Well, another question. Oh, wait, you base that circle off. That circle is off of the dimension.
Correct. Yeah. My dimensions, I would then take it that step further. And like you said, round the 12.598 to something nice and then have, nicer numbers to, nice English increments for each one of those lengths of those links. So now we would record our length of link number 2 is 3.130. And then the length of link number 3 is going to be 9.469. We have, our L1 in this case. L1 for this one is going to be the distance between the 2, but it's an inline dimension. So this 9.38, using the dimensions that we used, that would be my L1 in this case. Okay. You'll notice that if we look underneath, that's the distance of L1 between those 2. Okay. Sure. This one? That's not L3.
Now,
This would be L3.
oh, that,
Mm-hmm. I don't know.
Is it you do, oh, I see. It.
Yeah.
You're gonna divide it by 4.
Yes, you divide this by 4 because that'll be one of these chunks, and then this is gonna be 3 times one of those
Yeah,
chunks.
I flipped
Yep.
along. Right, it's not the top one divided by.
Oh,
It's
okay,
It's the 1, 2 combined,
correct.
divided by 4.
Right, right, so that you can get the L2 first, and then you can then get that difference. Mhm. Jason, do you have any questions? If not, that's totally fine. Totally fine. So, so there is hopefully a good process. I mean, you would have to go back and kind of, tidy this up, take your numbers, fill them in. You still have to show, I don't know, there's really not much calculation in this one. It's more laying it out properly. And then you do have to do one calculation at the end, and that's going to be for W2. So W2 is just one revolution divided by the total time again, but then you have to convert to RPMs. So make sure that you do that. So I'll let you finish that up. I think I'm hoping construction wise, that was probably where most people were kind of curious. Okay. All right. If that's the case, then what I'll do is I'll stop the recording here.